critical reflections and charting out way forward. So before we start, there are some instructions. Kindly put your mobile on silent mode, and we will try to stick to the program schedule we have mentioned, the timings we have mentioned, and there will be discussion at the end of each session. So you can ask your question at the end of the session, and then three of the whatever the speakers, they will respond at the end of the particular session. So before I would like to say something about FMES and NITI Institute. So Forum for Medical Ethics Society is organization from Mumbai, and we are working on 3 platforms. So we have a journal called Indian Journal of Medical Ethics. So that is a quarterly journal, and apart from that, we have another platform called NPC. So we organize every 2-year National Bioethics Conference. Third platform is about the bioethics training. So we conduct training in clinical ethics, research ethics, and public health ethics. So recently we had organized a number of trainings across India on Kolkata, Bhubaneswar, and one we are organizing here in IIT Bombay. These are the 3 initiatives we are currently working on, and we have received some grant from Tata Trusts, and apart from that, we organize public engagement meetings and roundtable like this to discuss about the issues which are pertinent and very much relevant to the contemporary context in ethics. So after that, now I would like to invite Professor Jha from Center for Policy Studies to say a few words about the center here in IIT Bombay.
We started our programs in 2016 with the PhD. We have young center in terms of how other departments in IIT are structured, and we have a lot of interest in areas particularly related to information economy. There are several aspects. I'm not going to go through all of them, but I really appreciate that we are have an occasion to collaborate on this area, healthcare, AI, and I'm willing to talk to anybody over the break if you're interested in any sort of other things that we do at CPS. And so you're most welcome. I hope you have a good time. Thank you.
Hi, my name is Isha. I'm currently a PhD student in sociology at the University of California, Irvine. I'm here to rapporteur for the conference today, and my background is researching technology, gender, and health in India. I previously did a master's at IIT Madras.
Hi, my name is Anantika. I work at CPS, and I have a master's in gender studies from Tata Institute of Social Sciences. And I'm here to rapporteur today.
Thank you both of you for being here and helping us with the documentation of the group. So I'm Sunita, and I work with FMES. I'm by training an anthropologist, and I'm also trained in bioethics.
Hi, I'm Lubna Dugal. I'm a managing committee member of the Forum for Medical Ethics Society, and I also work at the Economic and Political Week.
Hi, good morning. I'm Ashish. I work for a not-for-profit policy and technology think tank called C-STEP. By career, I've been into IT industry for a long time, and currently for last 2 years, I've been focusing on building solutions involving AI and other digital platforms for socially relevant areas like healthcare, urban governance, and now even in defense.
Good morning, everyone. My name is Ganesh Kumar. I'm a scientist in National Institute of Criminology, which is one of the Indian Council of Political Research Institute. My area which I'm currently working is on health system research and disease surveillance. So we explored in incorporating some of the health informatics solutions in both these areas. That one area which we are currently exploring is artificial intelligence to address public health problems.
Dr. Swati Rani. I recently finished my PhD from NITI, and the topic was influence of physical work environment on nurses' practical outcomes. It was a study in public hospitals of Maharashtra, and the base were nursing staffs. Basically, I'm a nurse entrepreneur with masters in hospital administration from NITI and of 20 years of hospital planning background. and that is the core area, that is physical work environment planning, and how it has effect on the patient outcomes and the nurses' outcomes. And I'm looking at working on nursing policies right now with the nursing advisor of India.
My name is Ramma. I'm from Times of India, Delhi. I write on health policy, especially with the new government saying that further announcing that they want to use AI in healthcare. And since we know most of us in journalism know so little about it, I thought I should come here and bone up on what it's all about.
Hi, good morning. Myself, I'm Se-1. I'm a doctor by profession. I'm personally doing my public and PG on the Institute of Hygiene and Public Health at Kolkata.
Very good morning. I'm Dr. Manju Shankar. I'm a medical oncologist by training. I'm from Tata Memorial Hospital. I treat blood cancers. I'm here as a representative of National Cancer Grid, a grid which is composed of, as of now, 160 cancer centers, research organizations, and the other NGOs involved in cancer care, with the sole purpose of making cancer treatment uniform across the country. Thank you.
Hi, I'm Nikita Surani, public health professional currently working with FMEs.
Hi, my name is Harish Iyer. I'm a senior scientific advisor at the Gates Foundation. Interested in research and development in health in India, and I'm come here to learn more about how civil society is thinking about this.
Hi, I'm Cheryl Thomas, and I'm doing my master's in hospital administration at the Tata Institute of Social Sciences.
Good morning, I'm Uma. I'm working as a MSW in GS Medical College and Caring Hospital. I recently did my PhD from Tata Institute in Health Economics, and also I did my A.Litt from Mumbai University.
Good morning, I'm Professor Sharvali Shukla. Currently, I'm working with Se-1 Statistical Institute as a professor and director. By training, I am a medical statistician, and my area of working is I normally work on DOHA concept, that is developmental origin of health and the other disease. And my area of working is longitudinal data analysis. And yes, I work, being a statistician, I work in big data analytics and its implications in health.
Good morning, I'm Santosh Dixit. I represent Center for Translational Cancer Research, which is a joint initiative between Prashanti Cancer Care Mission and ISA Pune. This is a young institute which is just coming up. Our primary focus is work on breast cancer from multiple angles, including genetics. We have just embarked on some projects on artificial intelligence applications in breast cancer diagnosis. And this is a growing area, and our center is interested in this space, and that's why I'm keen to be here.
Hello, I'm Danny John. I work as an evidence synthesis specialist and health coach. My work in artificial intelligence is basically using machine learning techniques for identifying data from published literature. I do a bit on computational health economics, essentially using machine learning for estimating future costs and future economic vulnerability.
Hi, I'm Amar Jasani. I work as an independent consultant and teach bioethics and medical ethics in different institutions. I'm also editor of Indian Journal of Medical Ethics. And I don't know much about artificial intelligence. I've just come to learn here. I don't like numerical data, but there's a lot of discussion for sheet data and all. So I think it is very useful for my own understanding.
Good morning, everyone. My name is Anand. I'm a medical doctor by training and work as a researcher in the health policy, ethics, and global health space. I am also an adjunct professor at University, Bangalore. I am a member of FMEs and I'm part of the organizing group for this event.
I am Dr. Ashwini Kalanti. I am an associate professor at the Institute of Medical Sciences, Se-1. My areas of interest lie at the intersection of health and technology, and I have no voice as far as AI is concerned, but it is a very interesting branch where I would like to learn more.
I am
Surajit Nandi. I'm a doctor and a computer scientist. I work at a startup called Raxa. We do health AI. I'm going to hear about some of what we do later.
Hi, I'm Dr. Sethi. I'm an assistant professor at IIIT Delhi. I'm a medical doctor by background and then moved to do a PhD in computational biology. So for the past 15 years or so, we've been working in the space of data analytics, ML and AI. We build models in our lab which target intensive care outcomes and community health outcomes such as washing measures and their impact on maternal childhood.
Good morning. I'm Shivaram Kalyan Krishnan. I'm on the faculty of the Department of Computer Science and Engineering here at IIT Bombay. I specialize in AI and ML. I teach the AI in my class. I do my research in AI and ML. I know next to nothing about healthcare, although curiously I've been called today to speak about it. My name is Vishwa. I'm the faculty with the Center for Policy Studies. My focus has largely been on inequality in public policy and the role of technology in furthering or helping with the inequality.
Hi, I'm Sambuddha. I'm a postdoctoral fellow here at CPS, and my interests are in social determinants of health and workplace.
I'm Radhika Radhakrishnan. I am a program officer at the Center for Internet and Society in Delhi, and my work focuses on feminist perspectives on artificial intelligence, especially.
I would like to invite Professor Jha to chair this first session. So, Professor Jha, you can take it.
So each speaker is given 20 minutes. I'll let you know 2 minutes before the time closes. And I'll try and make it clear that you need to stop at 20 minutes. So I'll just briefly introduce Professor Shivaram, who is our first speaker. Professor Shivaram is an associate professor in the Department of Computer Science and Engineering at IIT Bombay. His research interests include artificial intelligence and machine learning, as he's already mentioned, spanning topics such as sequential decision making, multi-agent learning, multi-armed bandits, very interesting, and humanoid robotics. Professor Shivaram received a PhD in computer science from the University of Texas at Austin. Subsequently, he was a research scientist at Yahoo Labs, Bangalore, and an inspired faculty fellow at ISC Bangalore. His contributions to robot soccer have received 2 Best Student Paper Awards at the annual RoboCup competitions. Professor Shivaram was also a member of the first study panel of the 100-year study on AI, which in 2016 released a report titled AI and Life in 2030. It's Professor Shivaram.
The report that was spoken about defines it like this. If there is an activity that humans once performed, which machines are now performing, that must be counted as an instance of intelligence. So examples of this might be the ability to hold a conversation, maybe recognizing objects in the environment. So that's a very human-centric view, right? So humans are not able to process like data coming in from galaxies and identify new stars. AI should be able to do that too. So an alternative definition is AI is that activity devoted to making machines intelligent. And intelligence is that quality which enables an entity to function appropriately with foresight in its environment. Again, whatever that means. So you can use these as placeholders. The point is, AI is something that you know it and you see it. Okay, and we're seeing it all around us today. You can talk to your phone, give it voice commands. There are cars driving around in Arizona and California. This community should probably know like robots are assisting in surgeries. A couple of years back, NITI program beat the human champion in the game Go. Go is a lot more complex than chess. This was like almost like putting a man on the moon. Happened 2 years back, thanks to AI and particularly something called reinforcement learning. So why is this happening? Why is AI suddenly in the news? 10 years back, we wouldn't really have had a meeting like this to talk about these possibilities. So what's happened in the last 10 to 15 years? Primarily, like the internet has grown, which means there are pipelines for getting data from all over the world quickly, reliably. And more so, not just data data in like sort of centralized digital format. I think this is still from 4-5 years back, but you can see that the amount of digital data that's stored right on the internet is has sort of grown exponentially. I'm sure it's continued to grow that way. Okay, there's only more and more coming in, especially as there's been a proliferation of hardware sensors. Right, phones are cheaper. Everybody's taking so many pictures. There are specialized sensors, CCTV cameras. You name it, you have it. Right, and all of these have become cheaper, more capable, right, faster. And all of this is contributed. But this is the point at which I will sort of stop and say, like, this is all very well, but I think AI people should take credit for still making it happen in spite of all this support. So the real conceptual progress that has made AI possible is growth in the field of machine learning. Okay, so rather than really telling you all about AI, I'm going to focus on machine learning, which is a paradigm by which you learn models from data. Okay, I'm going to give you like a maybe 5-minute primer, but this is really the basis of a lot of why AI is working today. Thereafter, I'll tell you my views on things possibly that this can do for the healthcare sector, what challenges stand in the way, and how to go forward. All right, good. So, suppose I show you this picture. Okay, you can see there are two variables, x1 and x2. There's a bunch of points. Some of these points are called plus, some of them are called minus. Okay. Now, if I ask you, there is this point over here. Is it a plus or is it a minus? What will you say? Minus? Somebody going to say plus? It's not really wrong to say plus, but the natural thing, looking at it, we sort of know intuitively it's got to be a minus, right? But then it's more than intuition. Presumably, what you're saying, right, on the basis on which you're saying minus is, in your own mind, you're drawing a line that is nicely separating the pluses and the minuses. Something falls on this side of the line, you're going to call it a minus. That side of the line, you're going to call it a plus. Okay, implicitly, that's what you've done. But if that is what you have done, there's really no reason for you to be doing it, right? This process is completely implementable as a mathematical problem. Okay, so imagine on the right-hand side, you're doing basically the same thing. You're given a bunch of data in a table, right? X1 and X2 are those parameters. They have values in the corresponding table. You go through the data and learn this model. In this case, the model is a line. Okay, and the idea is if you have a model then given a new data point, you can use that model to predict the corresponding data. Okay, so this is a very simple idea, but this is really the heart of what is called supervised learning. This is called supervised learning because you have labels associated with the data. Okay, but why is this an interesting idea? Well, this what I showed you was just like a simple illustration in 2 dimensions, but these points can be high dimensional. Okay, it doesn't have to be in a plane, it can be like 1,000 dimensional or 1,000,000 dimensional. You can still have pluses and minuses and draw these lines. Where would you want to do this? Imagine that you want to recognize faces. Okay, so each point can be like a 1,000,000 dimensional vector containing zeros and ones. The zeros and ones coming from a picture. Right? Imagine that you have a 1,000 by 1,000 picture. You have 1,000,000 pixels in each of those 0 or 1. You have a 1,000,000 dimensional point, and the label can say, does this picture contain Shivaram's face? Or does it not? Okay? If you have like lots of positive and negative examples like this, then you can learn predictor which given a new picture will say that's Shivaram or that's not Shivaram. Okay? So the math behind that is what's being done by supervised learning, used for detecting credit card frauds. A point can comprise of what time of day is the card being swiped, how much money is being transacted, when was the last time this card was swiped, right? That's 3 features. On the basis of that, if you analyze historical data, maybe you know some of the transactions were fraudulent and some of them were not. And so now, if you have this predictor, then when somebody is actually swiping, you can either deny or accept the transaction based on what your model says. Okay, sentiment analysis is something people do with natural language processing. It's big money now, right? People write on their blogs, this new product from Airtel is good or bad. Can you actually just go through the text, represent it in some way, and say this is a positive sentiment towards the product or a negative sentiment towards the product? At its heart, right, the technology is still that same thing. Alright? I think we're missing a little bit of on account of the. Do you mind if I did it like this without the? Let me do it without the full screen. Okay, so one complication which is very characteristic of practice is usually your data are not linearly separable. Okay, that's how we started explaining. But if you find a data set that looks like this, right, you can't really draw one line that separates the pluses from the minuses. But really why AI is so much in the news right now is we've made progress in being able to learn learn non-linear boundaries. Okay, a number of applications, particularly ones which come with visual input, audio input, and this is called deep learning. Okay, there's a particular way of doing supervised learning using neural networks. You can make these neural networks really large, which allows them to represent very complex non-linear surfaces. And empirically, we found they're able to learn such concepts. Okay, so this is why AI is in the news. Before going ahead, I just want to tell you, not all of AI is machine learning. There's also like other areas. Just take you like let you take a glimpse. But the fact is, many of these things are also starting to work because internally they are doing something data-driven. Okay, so if you have to pick one thing in AI that is really like making the difference right now, it is learning. Okay. Now, what then does this mean for us, right? For the healthcare sector, I told you I'm an outsider, alright. So I'm just thinking about some of this might be like very obvious, some of this might be infeasible. That's for you to decide. But one thing to mention, I just thought I should situate this in context. So yesterday I was preparing for this talk. I did a Google search for healthcare and patient, okay, on Google Image, and it looked like this. Okay, so I mean, it would be great if all interactions are like this. The doctor and the patient are holding hands and smiling at each other. The reality is it's not like this. Okay, so if we are contending with the Indian context, it's going to look a little bit more like that, right? People queuing up, fighting over each other to get registered to enter the hospital. And if you do get in, right, you're going to contend with the general mode. It looks a little bit more like that. Okay, so really, like whatever I'm proposing is assuming that the context looks like below rather than above. Okay, so I'm not going to propose precision medicine and personalized healthcare and things like that. The things that are a lot more feasible given our constraints. Okay, so here are some examples. Here's a very nice example of supervised learning itself, exactly what I told you in the illustration. So if you have some background in OBG, right, you will see that these are standard readings coming from a woman who's going to like deliver very soon. Okay, the top panel shows the uterine pressure as a function of time. At the same function of time, the bottom panel shows the fetal heart rate. Okay, so every time there is this happening, okay, C means contraction. You can see the pressure goes up and then the fetal heart rate goes down. So apparently, right, very close to delivery, it can sometimes happen that the contractions reduce the amount of oxygen that the baby is getting and can get hypoxia, okay, which is like a dangerous condition. And the fact is, if you are a trained OBG practitioner, by looking at this, you will be able to say, it's okay, don't intervene. Or you might say, no, alarm bells are ringing, let's go to a C-section. Okay, but the fact is, does it need an OBG person to make that call? So what this paper does, and which was followed up, is the development of a machine learning algorithm that can look at these two time series data, right, and then actually make the prediction. The way they did this is they gathered data with labels the doctors initially gave them, learned that model. Now they built that device that runs the model, and online, right, when people are there in the maternity ward, it gets this data, and if it looks abnormal, it's going to raise an alarm. Okay, so this is one, I think, very nice illustration of what machine learning can do, particularly in places where you don't have enough doctors, like our own country. The most popular application, I think, is ones in pathology and radiology. There are claims that deep learning can do better than human radiologists on certain tasks. Does somebody know what is the disease happening in the brain there on the right? Top right? It's not a fair question. I read it up. Apparently, it's called small vessel disease. Okay, and at small vessel disease prediction, the deep learning algorithm does better than the radiologists. Can also do like pathology very well. Okay, so these are some positive directions. I was very pleasantly surprised this morning to run into Dr. Desh, who's sitting there, who's one of the authors on this study. This was done like a few years back in Delhi. It's called the Poseidon study. I don't think this is very fancy AI, but it just tells you what you can see and do with proper data collection. So on a single day, they collected data from 2 lakh patients visiting primary healthcare centers. They've nicely plotted. It's probably, I don't know, the font is a little bit small. The x-axis is really like the age of the patient, right? Going from 0 to 60 years. The y-axis, each of these bands corresponds to one type of disease maybe. So the most common, people most commonly go to the doctor with respiratory illness. Least common is maybe genital sort of diseases. You can see how these vary with time, right? And this is precisely the kind of data that can inform policy and such. So this really tells us the power of data and what we can do with it. Even if we don't do fancy things in AI, right? There is a lot to be gained. This this is probably not very specific to the Indian context, but it's not really human feasible for a single person to digest all the medical literature and know exactly the right thing to do when the diagnosis has to be made. Alright, but the hope is that a learning algorithm which can at least go through all this data can, in principle, do a better job. I mean, at the moment, I don't know if algorithms have really reached that level of proficiency in inference and such, but it certainly is a possibility that staring in front of you are symptoms, you want to do a diagnosis, you have an assistant which is really like parsed and digested what is there in the medical literature, and it gives you useful help. Alright? So this is work in progress. I know different teams are working on this. In fact, I think somebody here mentioned doing something similar. This is also something that can potentially help in the long term. It's happening, right, in various sectors, including healthcare, that a lot of sophisticated hardware is being phased out in favor of doing the hard stuff in software. Okay, so where maybe you needed a sophisticated instrument to look at people's eyes and detect cataract, you can do it now with your phone camera and maybe a little bit more. Okay, some simple devices, and the idea is these things can be deployed far and wide in the field, right? Not necessarily they don't have to sit in the urban centers, and to actually do the detection right there, right, or at least gather useful data for doing it. Okay, this is one thing that I thought might be relevant over here. Although we don't have so much data in the digital domain already, I do know that Indians are not that bad at record keeping, except the record will be sitting in a file somewhere in a godown. Okay, if there is intent, right, if people want to get that data out into the digital domain and process it, AI can actually help. Okay, so optical character recognition is fairly well oiled, right? It's like a reasonably well understood topic now, to the extent that you can scan in text, right, and get text. I mean, recognize the text from the pictures, which will then allow you, for example, to search through these documents. So what's going on here is here's a picture of a book, and on the right is the text extracted from that. Neither of which you can see, I think, because it's too small. Let me go back to full screen. Okay, never mind. Okay, let me just take my word for it that you can do OCR. Alright, yet another application. This I'm mentioning because actually there's some local context. One way in which not necessarily AI but information and computing technology can help is in training. Okay, if there's a shortage of trainers, right, particularly at the low levels. Imagine training nurses to do certain tasks. Video-based tutorials can help to a great extent. Okay, I don't think they can suffice. They won't completely do the job, but they can probably save a lot of labor for instruction. There's one positive example here, right on campus. One of my colleagues has built a bunch of tutorials that I'm told people at Tata Memorial are using for screening certain types of cancer. Okay, so there's a tutorial that says if a person is to be tested for cervical cancer, here's how you do it, right? And the nurses use that tutorial to a good extent. Okay, and this of course can generalize. But okay, what are the pitfalls, right? Why is the world not so rosy? Foremost, I think in the Indian context, this applies across sectors, but I think also to healthcare. We really don't have data coming in. You see that everything that AI is doing is, most of what AI is doing is starting with data, doing something with the data. But where's the data? And if you want to make those predictions about hypoxia, you need those signals coming in for an algorithm to be able to train on it, right? And this is really not a done deal. It's not nowhere as established, right, or reliable as it could be. Okay, this is I think foremost. I don't know if this is foremost or if there's a tie to break with this second point, which is that I simply don't think we I don't think we have enough doctors, enough medical personnel, enough resources. I'm sure you know, and you will agree. And I think this is really an elephant in the room. Right? I don't think AI can really bypass this shortage that we have. Why? So foremost, I think really to take AI and AI in healthcare forward, you need people who are trained at least to some extent in both disciplines. Okay, I don't think I can do it. Right? I know the AI, I don't know the healthcare, but I know that unless I know the healthcare, I won't be able to do like a decent job of it. Okay, and I don't think there are established programs for really making this happen. Okay, Dr. Tesh sitting here is actually as an exception. Right? So don't go by his presence. I think it's we don't have like a systematic way of generating people like Dr. Tesh.
You're planning to get there slowly, yeah.
Good. If that is not happening, at the very least, existing doctors should have time to work with the AI folks and vice versa. And I know the doctors are overworked. Okay, they don't have time to do the regular stuff. They're burdened with administrative load. If you go to an OPD in one of the general hospitals here, you see never-ending lines. So where do they get the time to really reflect an abstract and do some sort of extra work? So again, that is something that is a limiting factor. Likewise, right, people who are trained in AI, my own students, there's very little incentive for them to go to the other side, right, to actually do the hard yards to understand the medical field, right, build products. Because, I mean, they come out of college, they're lapped up by investment banks, right, Microsoft and Google, who are going to pay them a lot of money. And people react to incentives, right? Maybe there'll be 1 out of 100 students who has his or her heart in the right place and things like that. But I think we need to have a more systematic way of attracting our engineers, right, to join work in the medical profession. Also, not just the sort of high-end, high-skilled people, but also like at the lower levels. For data entry, for example, maybe doctors don't have to do it. You need to have like a support staff. And I think we also lack, in that respect, in not having enough hospital management systems, something that you can take for granted for support staff. There's also this perception, popular perception, where it does magic, right? That you sort of give data and then it will give like magic out. It seldom happens. In fact, it doesn't happen. And I think people tend to believe that because you only see the positive examples, right? You don't see the instance of where that it just did not work and there's 99 of them everyone that did. So this perception is not correct. To get it to work, we really need a handshake and a very genuine partnership from people in the domain. Okay? So you don't have to take my word for this, but I highly recommend for this audience this article on IBM Watson, right? The software came out a few years back, which made very tall promises upon which it was not able to deliver. Okay, look for this on IEEE Spectrum. But in about a minute, I have to finish. So I thought I'll finish up with a bunch of do's and don'ts. Foremost, I already said, I think we should try and create an educational structure for people who can work in this area of AI and healthcare. I think AI should not be viewed as something that can replace existing decision makers. Really, to onboard it, it has to be something that is used as a supporting aid, right, and slowly ramped up. Don't trust AI yet. Okay. It's unlikely that systems that have been deployed in which work in other places are going to work as is in India. Much better strategy really is to start bottom up from our own problems, our own local context, and build out incrementally. I don't think AI can happen by diktat, right? One fine day the government says everybody has to do this, right? Much rather you have like a small number of pockets which show by really doing, right? The certain practices work, and then that gets wider adoption. Last but not least, maybe I don't have to mention this because I noticed the program has some portion devoted to privacy and security later today. But that's, I think, something we need to take very seriously. And the other thing to do with data is people want to have all of it. Okay, that's happening in other sectors. It's probably going to happen here too. We need to watch out for monopolies. And on that note, I'm finishing up. So, thanks.
Amit Wadkar has completed his Master of Philosophy in Social Medicine and Community Healthcare, so Health from Center of Social Medicine and Community Health, JNU Delhi. Masters in Social Work with specialization in Urban and Rural Community Development and Bachelors in Chemical Engineering. Previously, he had been working with the NITI, I'm not sure if I'll get it right, but NITI Shuruvak Shilpi Kendra, Indore, Madhya Pradesh. He was working on diverse issues such as campaign against unethical clinical trials and research and advocacy for silicosis disease victims. And he has done his MPhil from Center for Social Medicine and Community Health, JNU, New Delhi, pursuing his PhD from the same.
I'll be talking about locating AI in healthcare in a broader context of health for all. So mainly I'll be focusing on the political economic perspective. So we'll start with the two case studies. One is that is WHP SKY program. So this was implemented in Bihar, around 12 districts of Bihar, and by developing network of more than around 10,000 healthcare providers for a treatment of access to children suffering from diarrhea. So the telemedicine was the health technology here, and the approach was more like a hub and spoke model, which is very much top-down approach, which led to the initial evaluation shows that the program is improving the access, but later on detailed evaluation found that there is no improvement in the treatment access, and the prevalence of diarrhea and pneumonia was still high. So the planning was made top to bottom, and the people were not oriented to the technology, which led to the failure of this program. So when it comes to the AI, there is a C-tuple AI diagnostic application, which backed the biggest funding of the around USD $5.8 million. It has applied AI technology to visual medical data of blood smear slides to improve the accuracy of speed of the diagnosis. So it has claimed to enable the cost and faster diagnosis. But our main concern is the same. If the ground reality, social, cultural context of the particular country and the region has not been considered, then these technologies are ultimately going to fail, and health for all goal cannot be achieved. So we'll go through the development of AI across the world. So we can see as the countries like US, France, Japan, China, and UK have recently published the AI strategy reports and policy papers. But the main problem is that these all policy papers has the largest stake of the tech giants like Alphabet, Amazon, Facebook, and IBM. And main reason is that they have control over the big data. So that's why they are dictating the policies of these countries, except China. China can be exception to that. And the one we can see as a, for example, as corporate ownership of the AI-related paper is US is the highest. That is almost 6.6 and 4.1 times higher than China and Europe. So US we can see as the AI industry and agenda, whole research agenda is driven by the corporates. So there is another factor than most of the speakers, two of the speakers have talked about that. It's speculations of the consultancy firm. So there is a firm called International Data Corporation, which has forecast to achieve the compound annual growth rate of 37.3% to reach 76 billion. And in healthcare, they have the Frost and Savilian predicted that the application is expected to see an exponential increase in next few years. So these speculations are largely made to attract the funders and the venture capitalists and attract the funding. But the ground reality is completely different. So we can see as the funding trends in AI, in healthcare especially. So there are the two dips into the 2015, there is a one dip, and 2017 is there are many factors which were responsible for this decrease in investment. But as these speculative, these consulting agencies are speculating, the reality is completely different. And we can see as how the number of patents has been divided. Then there is a larger gap between developing and developed countries, and we can say as the US is holding most of the patents related to AI, and these are the leading countries, and developing countries are nowhere into this picture. So in India, so what were the milestones? So in 2017 there was a task force on AI which has been asked to write one report, following which the Prime Minister of India directed NITI Aayog to study a potential benefits of AI. So following that there was a conference AI for All which was convened by Government of Maharashtra and ORF, that is Observatory Research Foundation, which has roots in Reliance, and as well as NITI Aayog. The three of them organized this conference, and following which NITI Aayog published a discussion paper entitled National Strategy of Artificial Intelligence. So we reviewed this paper, but this paper is also missing the taking into consideration the local context and the complexity of, especially in healthcare, what are the complexities in data accessibility and digitalization of data. So the speculations of AI in industry in India, which are very much replicative to what the global trends are. So they have predicted that in year 2018, Indian AI startups
raised all-time high capital, that is about 29 million, which was just 3.52% of the what was the investment in the US. In the year 2015-16, there were highest number of startups, that is 91-95, but in suddenly 2017 that has deepened to 42. So there were very few AI industries which could produce the promising results and remaining setback. So, but the funding is increasing in terms of venture capitalists. So venture capitalists are taking over the most of the companies and investing into the AI companies which are producing the promising results. So investment is increasing, but the number of AI startups and applications are decreasing. So AI applications in healthcare. So basically we looked upon the whatever the research going on, and our research was review was limited. But we could find out that most of the applications were mainly focused on the minor health problems or some non-communicable diseases. So we want to pose the question as well that there is a research going on in some of the firms which are very much interesting and addressing to the needs of the country. But there are the researchers which are mostly into diagnosis. So we searched the profile of around 11 AI companies, and we found 8 of them were working on the diagnosis, development of diagnostic applications. So next I'll go to the barriers basically. Most of them has been discussed as well, but I'll go into the detail of 2 of them. That is, one is the lack of expertise, and Shivram has already discussed it. So lack of expertise. So compared to the developed countries, we can say USA was the leader of this, and in 2010 onwards they started investing more into this AI research, and universities started conducting organizing course around the AI research. China is recently has invested a lot in the AI research, and at least they have projected to have around 5,000 students who have in PhD in AI technology. And UK is also planned to build over around 1,000 government-supported PhD researchers in AI by 2025. But India, the figures are starting, and again opposite of that they have reviewed some of the profiles on LinkedIn, and they found only 386 PhD out of 22,000 PhD educators in AI technologies. India was ranked 30th amongst globally with just 44 top-notch presenters in the conferences which have been organized across the world on AI. About 70% of the papers submitted to Association of Advancement of Artificial Intelligence conferences were from the US. So mostly developed countries are dominating, and in Indian context the research is more concentrated in IIT and ISC. So second is the absence of data enabling system. So we know all the global controversy of Cambridge Analytica, how it fetched the data from Facebook and give it to their clients for their political campaigning. So their data leakages and data protection is always a concern. When it comes to the malware and spam attacks, India is the worst and second largest affected by these attacks. And we know all the Aadhaar controversy and what is happening to Aadhaar. So government website itself, they are publishing the Aadhaar number and all other biometric details on their website by mistake, and it has compromised the privacy. So recent Supreme Court judgment has talked about the right to privacy is the fundamental right. So this is actually this right has been violated several times. And after that, Sri Krishna Commission has also constituted, which came with the white paper, but apart from that, nothing has happened on that front. We see the status of regulatory framework. So in health-related data, that is the EHR data. So we can see as the high-level expert group on universal healthcare in 2012, it had first suggested for the digitalization of the health records. Then Ministry of the Health Family Welfare, it notified EHR standards for India in 2013, and revised Clinical Establishment Act as well mention about digitalization of the health records. But as health is a state subject, that cannot be implemented throughout the state unless and until states can accept the as a act. So draft of the following which there is a draft of the Digital Information Security Healthcare Act (DISHA) and establishment of national and state health authorities has been come up. So there are the hurdles. First is, I already said, like EHR guidelines are not legally enforceable. Second is the high cost and unavailability of the efficient IT and infrastructure and internet connectivity, especially in rural areas. And third one is the interoperability. So there are no guidelines. So each of the health institution or health hospitals, they are collecting their data and digitalizing in their own way. So when you want to interoperate among the hospitals and among the health service systems, it is facing difficulties because the data is not in a standard format. And the last one is the absence of the robust framework to address the concerns related to privacy, security, and most importantly, anonymization of the data. So there are the barriers in the access of quality data as well. So Indian health service system is very much complex. So people do access from faith healers to immediate health services like PHC, CLC, and they goes to the government hospitals and private hospital as well. So they go to quack as well. So they purchase medicines over the counter as well. So this the health seeking behavior in India is very much complex. So there is a challenge how to standardize this data, and when it comes to the intervention in the healthcare giving or like that. So how this data can be captured and how the AI will work in this context. And there is another possibility of giant tech industry tweaking the data. So there was a case of nanobrick in US which led to the overconsumption, which predicted that the possibility of diabetes in most of the patients, and which led to the overconsumption of medicine as well as the over-testing. So that has led to the much more controversies. So here we are, I'm ending with saying that if the local context, like the infrastructural barrier, the legal context, legal framework which we require, and the cultural context and social context is not considered, then each of the technology is going to fail. So if we want to achieve the health for all goal, then we need to approach from the bottom and to the top, and then integrate that AI technology into this larger framework. Thank you.
Policy and bioethics, and is also an adjunct visiting professor at the Department of Community Medicine, Yenepoya Medical College, and the Center for Ethics, Yenepoya University, Mangaluru, India. Thank you. Floor is yours, Anand.
Now, the presentation I'm going to do is probably just a very quick framing of some of the issues we'll anyway discuss in some detail. And I think these are issues which will keep coming up, so I will probably spend a few minutes on each of the slides, but not go into too much detail. Now, Rama started off with her introductions in the morning, talking about this news item which came in yesterday, which was speaking about our science and technology and health minister speaking about AI applications in public health. This was, I think, done in both ANI and PTI feeds, so I think it was probably covered in almost all newspapers. And I think there were two areas he talked about. One is that we are already using AI in Ayushman Bharat in trying to prevent fraud by hospitals. And the other area he talked about was actually cancer, and saying that we're planning to use AI in cancer research and also cancer applications, especially for screening purposes. So, and interestingly, if you look at the business standard piece, the Congress actually was lauded him for that initiative. So Jyotiraditya Scindia, one of the probable Congress presidents, actually said it's a great idea, and I support the fact that the government is actually investing in AI. So it's interesting that across the party lines there seems to be some interest in this domain. Now, one person who's been working a lot on these issues, especially around ethical and regulatory issues, is Dr. Eric Topol, who has written on this also. And this is a very interesting book. This is, I think, his fourth book, where he's spoken about the area of machine learning and also AI, especially in the context of healthcare. And he talks about the fact that we are already in the fourth industrial revolution or age, and here it essentially revolves around AI applications. And he also speaks about the fact that while this is extremely exciting and there's a lot which can be accomplished by the use of AI in healthcare, we also need to worry because of the one reason which he highlights quite strongly, which is the equity part, the possibility that we might actually exaggerate the profound gap which exists between the haves and the have-nots, those who have access and those who might not have access, and that this might actually keep on increasing as we use these kind of technologies. The one issue which keeps getting flagged, I think whenever you look at any analysis of AI applications from a sociology perspective and ethics perspective, is this fear that AI is going to replace a certain cadre of health personnel. I think Shivram alluded to that as well, saying that in some applications you will see that they do better than radiologists, or AI might do better than radiologists or pathologists. And this is a classical refrain. You will keep seeing that even in media reporting, that because AI is getting better over time, that there might be a time when we don't need radiologists, or we don't need pathologists, because you could use these technologies essentially to do a scan of any, you could do an image scan analysis, or you could do a slide analysis, or you could do a screening analysis, which is being done at a point of care, and then use that for either a diagnostic purpose, or even for sending that image to another, the treating clinician, not really be someone who's a diagnostician. So this is an issue which I think a lot of people struggle with. Obviously, there is the pushback then from those who are in those disciplines and saying, no, AI will never replace us because AI is never going to get good enough, or and those kind of debates which come in. And this, and this was also something which was played on by IBM, I think. And Shivram also mentioned the fact that IBM is a good case study because Watson had its own faults, but some of the ads which came in around the time when Watson was being introduced were like this, which is that, I can do much better than you because I'm based on machine learning, or I can do a computational analysis, whereas you as a single person might be able to do 20, 30 scans a day. I could do much better. Yeah, so that's. The other one is the possibility of harm, especially in the learning phase of the technologies, and one good example is the self-drive cars. So we already know that there's been at least one fatality in Arizona when this was being tested with Uber, where there was someone actually who was sitting as a backup driver in the car, but she thought that the program would be able to prevent against hitting a pedestrian, but the program was not able to do that, and the car ended up hitting a pedestrian died. And this is an example there, if we don't put in enough protections, especially in the learning phase, and probably even in the deployment phase, but especially so in the learning phase, we might actually have some risks attached to the technologies, where it might be a life and death situation. So that's where we need to, again, flag issues around risk. One is, what kind of potential problems could happen when there is the learning phase of the technology. Especially if we can get over-reliant on the technology and we get complacent, then these kind of events, as we talked about in the case of the self-driving car, could happen. And if so, who is accountable? Is it the company which is deploying it? Is it the regulatory body or the governance structure or the government at help who's responsible? Should there be compensation? Who is accountable for that compensation if there is harm? It's also because a lot of people worry about the downstream implications of adoption of these technologies, especially around discrimination. This is repeatedly flagged as something we need to worry about. If employers, potential, especially in nature, or insurance companies get access to data and they can actually use deep learning about an individual to forecast future risk of disease, for example, will that impact one, insurance premiums? If we are in the private sector market where you have to buy health insurance, for example, or if a company gives insurance to its employees, then decisions about employing someone versus not employing someone based on a probability that they might actually have something which is a chronic disease in nature and might require a lot of cost for the company, will that be something which we need to worry about? Because if the company is making a decision based on that because there is a future cost attached to that individual, which is not just a salary cost, but is a health cost, that might also lead to discrimination. It could also preference the needs of one section of the population over the other, and that is something we could call an input bias. We also talked about in the morning the fact that we don't have a lot of Indian studies. We have a lot of studies from the West which are being used to inform some of these machine learning and the development of the AI technologies. We have some exceptions. I think we have some experiences shared. Dr. Desh is here, Ganesh is here, and we have some work starting to happen in India, but still a lot needs to be done, especially in an LMIC context. So if these technologies are inherently based on data which might not be local or contextual, then will that mean that it might be data which preferences the needs of a Western population or a wider population when you don't have data on other population subsets? So that is the other area we need to think about. Some of the other areas which have been, there have been multiple analysis by groups which have looked at these more in a framework analysis kind of mode. So reliability and safety of these technologies are, what is the transparency and accountability mechanisms which exist around these technologies? Is there a possibility of data bias, fairness and equity? How is that being handled? How do you talk about trust in this scenario, and who needs to be part of that conversation? What could be the potential effect, not just on healthcare providers? We talked about the obliteration of some kinds of providers, but also on patients, especially in terms of their intersection with technology, which might not always have a human face attached to it. Data privacy and security, could there be a malicious use of AI? And if yes, how do you prevent it, or how do you respond to that? So in terms of trustworthiness, as I said, trust is an important area which those of us who work in ethics also focus on. The whole importance of not just at the individual provider-patient level, but also at the systems level, the importance of trust being hugely important. One example of why trust is important, for example, is the vaccine space. If you start losing trust in the vaccination system or the vaccination program, then you start to see an anti-vaccine sentiment rising. You could start seeing a dropping of vaccination rates, which could also impact public health. So that's why something like trust is foundational to the enterprise of health systems or public health. So what kind of issues would be relevant here? One is obviously transparency, which means are the operations which are at the heart of the technology visible to the user, or at least something which they can comprehend? Is there credibility? So the outcomes which you are saying will be coming from those technologies, are these acceptable, and are these also correct in terms of being technically sound? Are these technologies auditable? And if yes, who is going to audit them? Are these reliable, and are these recoverable? In the sense that if there is a failure, can you actually have a manual mode? Can someone actually step in if there is a technology failure of any kind? Or is this something where we totally lose control? Right? Now, the classical ethics principles that we talk about can also probably be applied, and we've already spoken about some of them. Justice could also mean the whole issue around bias, equity that we talked about, and where these technologies come from. Harming or not harming, and how to prevent that is something we will worry about. The whole issue of autonomy, who has control over these technologies, how does that impact privacy of a person and their right over their own information or data? The issues around trust, solidarity, and cost efficiency, because one of the arguments why AI is being promoted is the cost efficiency argument, saying once we have these technologies, it will be much cheaper to run some of the programs that we have. But also the issue of proportionality, which essentially deals with, is this intervention the best choice we have in terms of being the least infringing on rights of the patients involved or the communities involved, and are the costs and the utility proportional in nature? So the amount of investment that we are seeing is, are we seeing proportionate returns with respect to that? Now, issues around data and privacy are also paramount. One is, if there is data, who wants that data? We also heard from Sriram earlier that a lot of companies obviously want access to that data, and so that becomes an issue. Data here is a commodity in a sense. And so who has access to that data? Do other people also get access to that data? Is that transparently available? Are people who are sharing data as part of the enterprise also having some kind of rights on the benefit sharing mechanisms which might come in? What is the legal mechanism for this data sharing to happen? Are we just straight away signing off all the rights to the data by entering into certain kind of partnerships with industry, for example? Does the government have a role to play? If not the government, does a regulatory body have a role to play? Does an industry body have a role to play? Who exactly, and especially if it's transnational in nature, then how actually do we deal with that? And at the center of it, who consents for that data being given, right from the individual level to a state, probably health system level, to the national health system level, to this international sort of exchange of data, which will be at the heart of a lot of these technologies, right? Now, a useful framework was built by Wellcome Trust in this paper that they came out with on ethical, social, and political challenges, where they talked about the fact that there were around 10 important questions that they highlighted, which we should be asking. The first one being, what would be the effect of AI in relationships in health and healthcare? How is the use, storage, and sharing of medical data being impacted by AI applications in healthcare? What are the implications of issues around algorithmic transparency and explainability? Will these technologies help eradicate, or will they actually exacerbate existing health inequalities? What is the difference between an algorithmic decision and a human decision, and how reliable might both be? What do patients and members of the public want from AI and related technologies? How should these technologies be related and who should be doing it? Just because these technologies could enable access to new information, should we always be using them? Or should we have some way of judging actually what needs to be allowed and what should not be allowed? What makes algorithms and the entities that create them trustworthy? And when we say entities, obviously we are also talking about research groups, by industry, by various entities which might have their own conflicts of interest. And what are the implications of collaboration between the public and private sector organizations in the development of these tools? Right? So this is a useful framework. We can give copies to you if it's useful. Another lens which might be useful as we're discussing through the day is the public health ethics lens. And one of the frameworks which is used in public health ethics is a framework which was written up by Nancy Cass almost 20 years ago, where she talked about the 6 steps framework which you can apply to any technology or any public health intervention. The first one, what are the public health goals of the proposed intervention? So if we want to deploy AI in healthcare, especially from a health systems perspective, what is our public health goal for which we are deploying these technologies, and how do these technologies fit into that goal? How effective is the program in achieving its stated goals? Again, a question we should be asking. What are the known or potential burdens of this program? Can these be minimized? And are there alternative approaches where we can avoid these burdens or risks? Is the program being implemented fairly? Right? And how can benefits and burdens of a program be fairly balanced? So again, this is a lens also we should be using for any new intervention in health systems, including AI, for example. Now, you have Cheryl and Srijit. I don't think Sunita announced, but FMES had run a competition, which was an essay competition. One of the topics was on AI applications in healthcare. And Cheryl and Srijit are winners from the AI category. And they wrote up very interesting essays, which will hopefully soon be published. But I wanted to recognize you in one of my slides by also highlighting that both Cheryl and Srijit actually have also raised some interesting issues, some of which I think we've already touched on, but also issues around within the Indian context, what are some of the areas we might worry about. In India, the issue that caste is probably not something AI technologists have thought about, but is an important framework to use or an important differential that we need to think about, caste, class, gender issues, and how those will be intersecting with the use of AI technologies, especially in terms of impact of patient outcomes. Right? If there are decisions made on things like withdrawal of care, which is often very much patient-specific in nature. For example, there is a deterioration of the patient, there are certain indices you might use based on clinical evidence that you have. But then it's also a conversation with that patient or the patient's relatives about, for example, withdrawing care or stopping care. Can you totally hand that over to a machine program and remove the human element to it? Is something people have worried about, and they also raised it. The access issues in terms of cost. Will this potentially disrupt a doctor-patient relationship? We already know that we have a shortage of providers, and will this further widen that gap that exists in our context? Issues around privacy, if there are judgment errors and medical negligence happening, then what would it mean for AI deployment? Who would be accountable for that? And the fact that, again, we've talked about AI, there are various definitions of AI. Do we all have a common understanding of what we mean by AI and its application in healthcare? Right? So it's something to worry about. Now, one of the streams we wanted to also start off in terms of discussion today is the public engagement paradigm, and I think some of those who work within the AI field also have made that argument, saying that we are already seeing a lot of overhype in the media, and that is also pushing away some of the good AI researchers from actually engaging with the public on a regular basis, or with the media for that matter. And he makes the argument that that is actually extremely important, because we actually need to weed through the hype and actually focus on what are the true issues, and also have a transparent way of engaging in a regular way. Otherwise, we will all probably get lost in the oversell which is happening, and the true potential of these technologies might get buried. So again, that is another reason why we've talked about the public engagement stream. Another argument which is made in a Nature article was that one of the things that is usually oversold when there is reporting is the fact that there is a consciousness paradigm, right? Will AI programs by themselves have some degree of consciousness? Will they make decisions on their own? Will they tend to dominate decision making if we totally hand it over to them? But what he argues is that, yes, we could worry about that, but what is more important is in our building stage, which is when we are actually constructing these programs or designing these programs, how do we place values and ethics at the center of the design, so that the programs also learn to be making decisions based on a certain set of values and also have an ethical learning paradigm as part of that design. And how do we get there is the question he asks in this. So one way of doing it might be actually looking at potential frameworks we can construct, and we are hoping that we will start discussing some of this today, which talks about standards, governance, oversight, responsible innovation, but also the role of regulatory bodies, the role of industry, the importance of trust, the importance of public engagement. So if we can start getting some of these conversations going today, I think we will at least go into a few more steps in progress towards probably building such a kind of a framework which is of relevance to our local context in India. Now, yesterday while I was coming in, this is a local newspaper which is published in Bhopal. I picked it up at the airport. Bhopal again is an MP, a small state, but you're already starting to see a lot of this kind of reporting even going into small-scale local newspapers. So, interestingly, what I told you was that AI can discriminate, but what this report seems to suggest is that AI can also detect discrimination. So it's interesting. AI seems to be an omnipresent force which can do everything under the sun. There is actually one paper which argues that AI is the new God because it's omnipresent, it's around you kind of a thing. So it's interesting. But as I said, the lack of standard definitions also means that we don't really know what we're sometimes talking about. Another airport snippet as I was traveling. Perhaps our most valuable intelligence isn't artificial, and that's why we have convened you all here in this room to actually discuss some of these, the paradigm of AI applications in healthcare, but also some of the issues that we are trying to highlight and how we might be able to deal with them collectively. Thank you so much for your attention.
Standardization actually in AI is about fitting the code. And the other thing is that actually AI today, AI has been around for the longest time. Today it's coming back in full force because there are various ways in which technology is being used to collect personal data. And health data is one such personal data. So the idea is commercialization of all of this data, not really about health. Because it's not being pushed by the medical profession, it's being pushed by the technology world which wants to get in and see what they can make of all this personal data. So how would we constitute our questions if we were to factor this into our discussion?
You commented that we should not trust AI as of yet. So, what according to you is the current state of AI with respect to healthcare, and how much longer do we expect to see that rainbows and unicorn AI to come in and help us?
You mentioned, gave us a blueprint for building AI in the future. And you talked about ethics as being something that we should put up front. In your mind, do you believe that systems such as healthcare are built with has the human system of delivering healthcare been built with ethics up front? Or is it, if you will, an emergent property of the practice of it, taking into account the constraints?
Sorry, I can't remember 5 questions, but I remember the one that was posed to me regarding I'm remembering that one.
Not trusting AI.
Trust, right? So if you, even just look at a couple of glimpses of examples where AI can go wrong, you'll see why not to trust it, right? So imagine taking like just a regular picture, let's say of a car, and taking like a few random pixels, maybe 100 random pixels, and then changing them from 0 to 1 or 1 to 0. You and I will hardly notice any difference. You'll still call it a car, it'll look exactly the same to you. But this is enough to throw off certain deep learning algorithms, which might originally be calling it car, they'll suddenly start saying there's no car. Right? So some of the systems we build, they'll get 99% accuracy on the data set on which they're being evaluated, but in slight sort of perturbations to the system, they can go way off. Right? This is one of the reasons, like self-driving cars, people are still scared to onboard them because a malicious person can actually change the lighting conditions or do something with the representation that throws them off. So as for when can we get to trust it, I think it's an empirical question, right? We have to start out small, and if it works without any such hiccups, then only with time, I think, can we say it's something that can be trusted. It's very hard, I think, to give that assurance upfront, and we should be wary of people who are giving their assurance upfront. This is in the context of health, but also more, I think humans have this tendency to trust things that are told you. Like you're shopping on Amazon, it says we recommend this product for you. You suddenly feel like exactly how did they get this right? But with time that can drift, and they can sort of shape your thinking in a certain way and interfere with your independence in choosing what you want to browse, right? So in subtle ways, the system is not doing exactly what it should be doing, but we might be inclined to think that it is. We should watch out.
I agree with that. Recently there has been a lot of push for the AI, and the main reason is we have a lot of data. And when I was reading one article by Gene Trace, he has also alleged that Ayushman Bharat and the health cards which has been prepared, the main objective is to fetch the data and give it to the corporates. So I see answer into the how to change it from the ownership to the big corporates of the data to the more to the people centric and the small startups which has their own say into the developing this kind of technology. Because if we see the trends that they never come into the picture, they come into picture when there is something application has been already produced. So they invest into that and then take over that company. So the Indian trends are like that, and there are the good examples of the AI applications as well. As we reviewed, and some of the startups are working very well. So who has the ownership of that data, and how the framework is there to regulate the data, and to whom to hand over that data. That is a very much question as well. And then in that I see that government has to play a lot of role, and they are playing at the which hand, then it ultimately we have to control. I don't know how to control and how to see that more democratization of the technology happens. It is very complex, and that's why we are here to discuss. And about your question, sir, regarding the algorithm and politics of that, I can see as the ownership of data is very much problematic, and as we say that the owners of the data, the huge data is they are the big giant corporate. So when it comes to the politicization, then ultimately they have say into everything. So we reviewed almost 3-4 policy papers of countries, and the stakeholders are from these corporates. So there are the chances. So I don't know what to say about how to tackle this issue. But I can say as government has a lot of role to play into the regulating all these things, so that the data cannot be tweaked in their own interest and interest of the market, and then it will more address to the unmet need of the population and people at large.
If you are asking me, is the current health system ethical in nature?
No.
That's just my rephrasing, just to respond to you. That's probably no, but
that's not my question.
Sure. So let me try and interpret your question. Is ethics something we are discussing in the paradigm of the existing healthcare system before we even talk about integrating ethics into AI applications in healthcare? Yes and no. I think the reason ethics or the field of bioethics grew was probably a few in nature. One of that was obviously there were egregious abuses of the kind we saw in the Nazi war experiments. But the other one was actually technology. So there were resource constraints. If you had a ventilator available and there were 5 patients who needed it, and maybe 3 of them had the same medical indication and probably the same survival chances if you use the ventilator, but only 1 ventilator available, what framework do you use? Because the clinical framework is the same, right? It's the same long-term survival rate that you will see. That was a moral question. Do you use age as a criteria? Do you use someone who's more professionally qualified? Those kind of questions, that is why ethics discussions around morality or ethics started to grow in nature. And I think we are seeing the same issue here as well. With any new technology, you will have these nature of questions which need to be asked. Because if you don't ask them now, we'll have downstream issues. We've seen that with a lot of technologies, that there are downstream controversies which happen, which could have perhaps been prevented if we had started thinking some of these important concerns upfront. I think the paradigm where ethics is always seen as probably a way of trying to stop technology or stop a new intervention needs to be rethought. What's more important is why are these concerns important and what can we learn from these concerns in the way we design our technologies and in the way we implement our technologies is something I think we're trying to argue here. So I think all of us here, at least from the organizing team, are very supportive of AI. And I would like to put that up front in the first session itself. We think it's good to start discussing this. There is a role that AI can play. Yet at the same time, we can't have AI and not talk about these issues because then we might fall into a spiral where it might be a slippery slope, I think. So I don't know if that responds, but I think we can have more conversations. If I can start off the next level of, next set of questions, maybe Professor Manju, if you can speak to some of the concerns Navneet raised around interoperability, the cost issues, standardization across institutions. That is something NCG has tried to struggle with, I think, over many years, and you had some success. Maybe we can start learning from that.
So, coming on to the, one of the things which we are trying to do as part of National Cancer Grid is to, make the EHR data across centers accessible. So, if the patient moves from one center to another center for continuation of care, they need not carry their physical records. The doctor who has, done things in the X hospital earlier, in the Y hospital, the doctor need not repeat that, and there's, almost like a continuation or a seamless integration of all the electronic health records. And as you rightly pointed out, in most of these centers, there are no two EMRs which are alike. They are different. Some of them are commercial, some of them are, built in-house. And so that we thought whether standardization of data is something which can answer that. And answer is no. You will never have that standardization of data ever between centers, and then you can, make it interoperable. So we need to learn some kind of patterns, and we are having a team from Iceberg who evolved the Aadhaar and facial recognition at the airport, etc. And they are helping us in this electronic medical record integration across the centers. So that's something which we are doing as a proof of concept, understanding that what patterns can be looked at and how we can integrate data across the electronic medical records so as to make things uniform. The second thing which we are trying to do is to make guidelines, the cancer guidelines, as far as management is concerned of cancer, and so that the treatment can be uniform across the country. Wherever the patient goes, he or she does not need to travel to tertiary cancer centers to make the treatment, standard treatment, to get a standard treatment. So that's something which we are linking now with the Ayushman Bharat. We are linking that there's cancer treatment guidelines to make things uniform. So this is something which we are doing in terms of cancer management.
Most of the issues which are being raised, I think, I'm slightly confused. The ethical issues about digitalization of most of the health data and AI, are they the same? Are they similar? Because making the health data digital, some of the issues that came up seem to be the same issues that you're talking about now in the context of AI. So are they the same concerns, or are they different? Or if they're different, how are they different? AI and digitalization of data.
In the 1960s, when technology was transferred to South Asian countries from the West, the newly liberated post-colonial societies, exactly the same discussions were happening about the appropriateness of technology to the level of development of society. So this is something that I'm also trying to explore as to, is there something additional concern that AI brings into the discussion on the effect of technology on society, especially in an unequal society like ours, which various levels of compounded inequality. It's not just the class, but the caste, the gender, the sexuality, age, all these things kind of compound out. The same discussions were made in the 60s. So I was asking Shivram, is there anything additional that AI brings that we have to be additionally bothered about? So that's also something that I'm curious to know.
Digitization is among the first steps moving towards AI. And if we watch all the systems as they are brought in, it's digitization first, then ID, then ubiquity, which means put it in multiple databases, through mandatoriness. Then there's the Internet of Things, there's AI. So it's all part of a pattern. You jump directly from digitization to AI, but it actually goes through all of this. And it won't work unless this is in place. And actually, I found it deeply disturbing what you say you're working with Iceberg, because Iceberg is at the center of commercializing all personal data. And they are at the center of breaking down any kind of rights among people, converting consent, for instance, into consent layer, and introducing this concept of JAM, which is entirely their doing, which is Jandan, Aadhaar, and mobile. Because with these three pieces of identifying, ways of identifying people, it's possible to track everyone across, and it's done through coercion. You have to have each of these if you have to be able to function on any system. And then that's linked up. So if you look at all the AI and health that's being talked about now, at the center of it is the identification system. So which comes after digitization. Then you link this with that, and then you link it with everything. And then you.
So in a sense, as a patient, I don't have a chance for consent to opt out of the system.
It's called consent architecture. It's not called consent anymore. It's a consent layer. So the whole idea, and it starts with saying that privacy is dead and consent is broken. So you build on that. So it depends on what your foundation is, the kind of system that you make. Which is why I would also ask for a rethink on this idea of data ownership. Because I don't think it's about data ownership. The moment you say ownership, it becomes transactional. And there are many things that are not up for transaction, and we have to be able to make that distinction. And within AI too, to be able to see whether there is a role for AI in personal data and a role for AI in non-personal, other kinds of systems that may come into place where AI might be helpful. And if they are two separate things, to decide where you want to, what you think will be useful and fair and just and not handing over for commercial use. It's just an anxiety that's slowly building up, I thought I'd express.
I'll just make a couple of comments. I think because these are important. You asked about trust and handshake. So I think from our experience, I'll just give a couple of examples from that. I work at All India Institute of Medical Sciences in the Department of Pediatrics as a Welcome Trust Fellow. Our experience with working with doctors, and I'm myself a doctor, is that doctors are open to AI. But they do not trust the AI because we do not offer explainability and interpretability of models. So as long as we are building explainable, interpretable, interactive models, I think that handshake is not that difficult to build, especially in Indian situations where doctors realize that we need to offload or to have decision assistant based. Of course, that does not mean that the decisions will be taken by the AI algorithm, but at least there is, I see, a buy-in right away if you offer models that are more explainable. And a lot of our work, especially in our lab, is around building explainable and trusted AI models. The second thing I think which was brought up about building common data models and having data as a first layer, I totally agree with that. West has tried to solve that by building consortium and building something called CDMs, common data models, and they seem to be successful across the globe. I mean, I know of these initiatives like Odyssey, which works with Korea, US, Norway, etc. Why can't we have something like that in India as well, where the HR common data models in India can be built, or even if we can learn something from the West in that sense. And I'm glad to hear that you're already doing that in that space. Really. Thank you.
Any responses from the speakers, and then we can close?
Sriram, do you want to tackle that foundational issue, like how is digitalization of data different from, say, AI? I think Asha, Susha responded to that a bit, but maybe more detail.
And also what Vishnu raised, I mean, I can have a couple of comments on that, but you are the AI person, and there are many other people.
Right. So actually, I interpreted your question as a very simple question, right? Literally, like, what is the difference between digitizing and then the AI? I think as she said, I mean, a lot of AI today is data-driven. The reason things are working is they are building models from data. Unless data is accessible in a digital format, a lot of the AI applications cannot be built, right? So we have this sort of dilemma. You need the data in order to build AI, but then comes the risk of that data sort of being misused, manipulated, things like that. So, I mean, that's basically, I think, what is being debated. That
so the issues are more or less the same. The concerns in that sense would be more or less the same.
Concerns between what and what?
like the concern that you don't have control over your own data.
Exactly.
That once you give up your data, it goes into something.
Well, you don't have to give up your data, right? Ideally, we should find a mechanism for AI to still have the data, but people not to lose sort of authority over their own data.
How does any human being do that? I mean, if my digital data is with the hospital decides to give it to a pharma company, how do I even know that's happening?
We have to make sure that the hospital can't arbitrarily do that, right? Presumably, that's what we're meeting here about. There must be legal sort of standards which legislate like what can be done and what can't be done. The other question about difference between technology doing this anyway and what's happening differently in today's AI world. I just think today's AI is a lot more in our face, into our lives, right? I gave the example of, I don't know, using a new motor or using a new car, right? You kind of know it's a different thing, right? You know what it is, but I mean, today's AI means you might be talking to a software, right? When you call up a call center, or with drones coming and delivering things to your house. It's really invading our private space in very unexpected ways, right? And I think that difference of degree of scale, the speed with which AI can spread is the difference. I don't think there's like fundamental difference, but it's really one of scale and nature and degree.
I think that's rightly said. It's a scale, and if I may say, just to add to what the conversation is going on, I think the way Rama, the data is being used, and when we say artificial intelligence, we are giving the decision making to that algorithm. And so what we've been sort of, the way I have understood the risk, at one level of risk is, if the quality of data is poor, then you'll land up with the decisions that are being made by that AI-based application could be disastrous. We do not know. And since if you look at the way our systems function, where implementation is so poor, there are no compliances, we really don't care about regulations and systemic kind of approaches to anything in Indian context. So for example, we have excellent laws, but if it comes to implementation, everybody knows what happens at the ground level, So I think it's a way, as Shivram rightly pointed out, it's a question about the scale of the issues, and the problems are much more accentuated. What one would think about what happened in 1960s, and it could be green revolution or motor or whatever. I think they're really of different kind. So it concerns. Yeah, sure. We can close. So we'll break for tea, 15 minutes.
So I'd like to thank all the three speakers, and we'll have a break and then